I'm so excited to introduce to you our new inductive kit for the Macan S and GTS. Hi, I'm Brian, an engineer here at TPC Racing, and here we have our new carbon fiber inductive kit made from dry carbon fiber with embedded aluminum parts.
This is an exciting product. This is a very exciting release. Everybody, I'm Michael Levitas. I've been with TPC from the very beginning. TPC was founded really in the grips of racing. I started out in the IMSA series, and the passion and the love of TPC in general has really been about racing Porsche cars. We started out actually with Nissans and with Mazdas. We had a Mazda deal, and that catapulted us into the Porsche market. And I'm so excited, like Brian is, to be involved in the Macan. I was asked early on to start developing some Macan products by customers, and I wasn't so excited about the car right away because my first response or my first passion has always been in sports cars. But I got to tell you, I bought a Macan. This is my car, and I'm not only drinking the Kool-Aid, I love this thing. It truly is a Porsche product. This thing's not about the badge or the marketing. This is an amazing car. And what we're doing is we're taking really the approach we've always done with all the cars we do. We look at the approach that Porsche took and how can we enhance where they are. We don't believe that we can necessarily reinvent the wheel, but we were just looking on, okay, why did they create this D shape the way that they did? Why do they have this together? Why are the turbos where they are? Got to remember, this is a brand new generational car. This is the 20 and up Macan 995B2 it's called, and this is called a Hot 6. And the reason it's a Hot 6 is right here. In reality, you really want the hot gas to exit the top. Hot gas rises in the cylinder head. So the proper way to do this in new F1 engines, very high-end engines, the exhaust is up, the intake's down. And you ask yourself, well, why over years did they start out with the intake on the top and the exhaust on the bottom? Well, that's easy. It was packaging. There were no such thing as computers. They couldn't get there. You had carburation. I mean, how do you have carburetors here feeding like an intake underneath? Now it's like you got direct injection into the cylinder heads. Anyhow, let's fast forward into what we're doing. I think Brian's done an amazing job with this project. I turned Brian loose on this early on and gave him the challenge of come up with another design, Brian. And he worked really hard at this, and it was many frustrating hours and months in doing this. But at the end, we created a package that the data from the flow bench, the data from everything that we've done has led us down this path to increasing the volumetric efficiency of the turbocharger. So what that's doing is, for all of you turbo guys out there and gals and anybody that's real geeky, is that by enhancing the compressor efficiency of the turbocharger, we're going to go ahead and reduce some of the crossover pressures. We're going to get free horsepower out of this. We're going to lower our charge air temperatures. As the efficiency goes up, charge air temps go down. As charge air temps go down, density rises, so does horsepower and performance. They go together. Also, don't be surprised to expect an increase in fuel economy as well. That's a possibility with increased density. So as Brian has been pointing out very incredibly, is Brian, to lead us into the development of some of the components. Start us with the airbox. Work us backwards from the factory airbox back.
Yeah, of course. So the first thing we looked at was how can we remove the restriction presented by the factory air filter. We obviously know there's a large pressure drop from ambient to into the filter. So what we did was we created a custom designed oiled cotton filter to fit perfectly inside the factory Macan airbox. And with this design, we actually managed to increase the filter surface area by a whopping 28% by adding filter media to the top and the bottom of our filter compared to factory. Mm-hmm. And we also redesigned this front filter panel to increase the plenum volume as well. And on the flow bench, we actually saw a 42% increase in mass flow compared to the factory setup.
Now tell me something, Brian. When working with the flow bench, because I know we were at the flow bench together, and a good friend of mine and an incredible local racer. He's been really running a cylinder head porting shop since probably about 1964. His name is Larry Ladd. He's a real celebrity in the area and really all around the country. We were fortunate enough to work with Larry, and I've been fortunate enough to work over the years on Larry's flow bench and to work with Larry in porting. So really what we did was we thought, okay, well, what a better exercise, and not only measure the cross-sectional area, you have calibrated, you have CFDs that you can run on this computer, but I mean, nothing beats going to the bench and seeing the real air movement. So what Brian's really saying is what we did was we started with the factory air box. We really built it up as it would be on the car. We put all of the chamber around this so that it was a true air box. And what we did was we ran this. It's very typical in a flow bench to run this at 25 inches of water. So that what that means is they've got a huge manometer. And so you're holding, and we've got a video we'll share later, but we did a video of this. So what we would do is we would hold the water at 25 inches, and then you start increasing the demand of mass air, which is measured in cubic feet per minute.
CFM.
CFM, correct. So keeping the manometer the same, you know that we're looking for a zero pressure drop across the media. So in other words, between the turbocharger and the media itself. So we're comparing apples to apples. It's not just like moving mass, like how much more mass air can you move at this? Because like Brian says, it's all about the pressure drop. And there's another predictive also. There's a table in the factory engine control unit, and it really is all about the pressure drop and the calculation of that because it's part of the computer model. So Brian, you go back into pointing your way through it, but he really did see a 40% number. We were blown away by this.
Yeah. So in addition to redesigning the filter itself, we also increased the diameter of the outlet right here. And with that, we had to redesign the silicone hoses as well. The factory design has this accordion to it, which causes turbulence as air is flowing through it. So what we did was we actually switched to a silicone hose that removed that accordion design and now allows for the smooth flow of air.
It is. I might point out one thing though in the factory's defense. You know, when you're thinking about factories, why would they do this? You know, number one, that has something to do with production. Number two, it also has to do with assembly and the assembly line. You know, they need to be able to, these cars are put together quite rapidly. And what is their target? You know, what's their target performance level? We're always looking to gain something.
Yeah, this type of material, it's EDPM. It's actually way easier to mass produce. Silicone is more of a slightly more complicated process compared to EDPM. This is pretty much equivalent to injection molding. This is layered on to a mold. So, but at the end of the day, this is the more flexible and more durable, in my opinion.
Why did you go with a larger area of inlet to the actual plenum? What was the reason for picking this up? Was it that you knew that you wanted to be able to increase the total number going to here, the actual density going to the turbos?
Yeah, I mean, we know that from our numbers already that this filter is capable of a lot more. So by increasing the diameter here, we pretty much open it up to allow that extra flow to really come through. And we also had the space in the engine bay and in that area to increase that diameter. So we were really just trying to maximize everything that we could along the way.
Interesting. Yeah, no. I mean, I'm a big believer in that because over the years I've worked on the flow bench with Larry, and we've learned quite a bit. And one of the things we've learned about the most is also having a charge area behind the valve. So when a valve's getting ready to open, you want to have a large plenum above it, which is like a pressure area, you know. That plenum area, that's why these plenums keep getting bigger. Brian keeps bringing up this number plenum, and that plenum actually means something. This has got a volume in here, and what you're trying to do is this is going to sit there until the demand is from the turbo inlet, whatever that demand is. It can be the throttle moving, and then of course you have an ingestion, you have manifold pressure. There's a lot of things dictated, but he's also leading you into the actual pipe. Give us a description of why did you stay, I've seen other people, Brian, and we had this discussion back and forth. You see others that take a path, and it's a lot easier path of just, why not just have two-inch pipes? I mean, like what, can you actually get more mass air through this than a two-inch pipes?
Yeah, so obviously if we were to look at this, if we were just not to think about why Porsche did what they did and just look at it from how can I make this the easiest way, it would make more sense to just make one long tube and have this here split out. But the important part with this section being a D shape on the inside is actually it provides even airflow to both turbos. Because the cross-section area for each turbo now is the same, you provide more even airflow to each turbo, and this actually overall increases the amount of air both turbos can receive.
And also, I don't know how many of you know this out there, but the D shape happens to be a favorite port for certain cylinder head designs. They'll put a D on a cylinder head because it actually will draw more combustion gas out of the chamber than a standard oval shape. There is something to the laminar flow. There is something to how it sticks against the wall, and you don't get like a laminar buildup or a stagnant area that the air is really not moving. There's a reason the factory did that. This is quite a design. I got to point out another thing. This is what came to us when we decided to make it out of the material that we did. We chose carbon for a number of reasons. One was lightweight. I love the appearance of it under the hood. It looks fabulous. What we were trying to do to produce this didn't allow for conventional methods. It had to be autoclaved. So what this is like two molds that were made. They took dry carbon, wrapped it. This was bagged, it was autoclaved. The parts were brought together. They were then molded in with the aluminum ring that you see here. And what you see is it's a perfect part. And this is what you would expect to see from TPC Racing. So I think the next part of our project, we are really right now introducing you to what we're working on. But the real proof is we're going to be going next into the dyno cell, and we've already been working with Cobb. Cobb is the stage 1 system that's currently in here. It's the Cobb tutor, so it's the AP. And we're going to go ahead and then put this back to the zero map, which is completely stuck. We're going to do a really nice job baselining this. Then we're going to come back with the addition of the increased mass air to the compressor, to the turbocharger, and see what type of benefit we can really get. I know that I rushed you into this. One important, I think, attribute is tell us about how this fits into the air box. And I do notice that on the factory, they keep a rain gutter.
Correct.
And are you maintaining this?
Yes, definitely. We wanted to design our parts pretty much mimicking what OEM would have done if they were to produce a high-performance version of this car. So that means we are retaining the factory airbox, the factory lid, and the factory rain gutter here, so that this is a fully daily drivable car. You can still daily this and not worry about weather conditions or anything like that. And the lid still protects your engine from possible rainwater that might get in. And the seal is still here because the seal actually allows you to suck fresh air from the outside rather than hot air that's been sitting in your engine bay.
Right. Yeah, that is a really good point, because if you were just to put two massive air filters under here and draw in all the hot air, kind of defeats the purpose of doing all of this. It's thrown out the window. There's a reason that Porsche draws all the fresh air here, pumps it through the hood, fresh air there goes into the inductive. The only thing they really worry about is some of the rain gutter effect. And then also it has to do with noise. You might try experimenting around. We will on the dyno a little bit. We'll do it on the street, but we'll work with modifying the rain gutter a little bit to suit our taste. For now, we're building it so that it has the factory installation.
Yeah. And one other point regarding heat from the engine bay, pipes that are in the car are made of stainless steel. And heat from the engine bay, especially since these pipes are very close to turbos, that heat soaks in to the air on the inside of those pipes. With the carbon design, it has a way lower heat transfer. into the air on the inside. So we actually see a cooler temperature of the air entering the turbos, which means that your intercoolers are able to do an even better job in cooling that air.
Well, it sounds to me like if you have a lower inlet air temperature, I mean, heck, like think about it. If you've got a turbocharged car and you're looking at the performance, so SAE corrected, when you're looking at corrected, it's correcting for the ambient temperature. But in reality, if you don't do things corrected, the lower the ambient temperature, the more horsepower you're going to produce because the density goes higher. So show us the factory installation.
Factory, this would be the airbox outside the car. It slides in to the airbox in this little groove here, and it clicks in, and this is the lid of the airbox. It goes on the top, and this allows you to drive your car in the rain, while this lid would actually protect your engine and divert any water to both sides where it can be drained out of the bottom. We wanted to maintain that feature with our design as well. So let's say we were to swap our filter into it, which actually maintains the factory fitment very well. It's a very nice fit into this airbox.
Now notice the size, the massive size of this filtration area.
Yeah.
It's not a cone filter. This is a proper filter.
So you can see this filter, because the filter has rubber on the back, actually sits very nice and tight inside of this airbox. And with the lid on top of it, it seals up very nicely. And from the top, your engine is still protected from water. We made the filter the exact size so that if any water were to go down, it would fall to the bottom and come out the same drain hole.
It's brilliant. We did experiment a little bit on the flow bench with rain gutter, and there was no tremendous benefit to having it or not having it.
Yeah, we saw a 1% difference.
Yeah, it wasn't the big one.
Yeah.
But boy, was I blown away by seeing a 40% gain in mass air. That is tremendous at the same inches of water. I mean, that was like, I was actually not prepared for that. Because when you looked at the filtration size area versus the factory, it was, it's amazing. There's something that you can't put together with the CAD model that the flow bench really tells you, like the distance that the filters together. We can't really completely model the pleated versus the cotton. There's just a lot of things going on. But the one thing is for sure, we did pick up 40%, which is a tremendous gain. Lead us into how the rest of this goes together.
Yeah, of course.
You're getting...
So we have our custom silicone pipe hose that adapts from our airbox.
Now notice one thing we did do, and we're proud of this too. Brian had the challenge of really had to not cut corners, wanted to do a nice job, wanted to have perfect fitment, but he also maintained having a groove both in the part and also the molded in, which did add cost, but this allows you to have really a perfect seal, and when you put your clamp on, you really do get a proper fitment. Sorry to interrupt.
No, you're good. Yeah, it also helps with installation and alignment because you can actually feel, as you're installing it, you can feel your part click into that groove so you know that everything's aligned properly.
You know, look at some of the other detail. Everything is maintaining all of your factory pollution control, crankcase ventilation. Everything is done OE. There's no venting overboard to the atmosphere. Everything's done in an OE fashion, which we're really proud to do.
Yeah.
This is really, what you're looking at right here is a completed product.
Yeah, this is how it would go in the car.
Yeah, and look at just the difference from...
Yeah, there's these little fins that are directional to the turbo rotation, actually.
And what they're doing is trying to cut down on some of this, trying to redirect the airflow because it's so tumbling around, it's violent. We've really paid attention to that in the design, and you can see how restrictive it actually has become. This part, look at this. I mean, there is just... Now, this also opens up for in the future, we're going to discuss it in later times, but there's also a method to our madness. Not only do we want to get more efficiency out of the factory turbos, But if the factory was creating truly a GTS or a performance model of this car, they would absolutely have another airbox to go with a larger turbocharger.
Yeah.
So, imagine everybody if you had this factory turbo package exactly as it is right now with no change, and you had a larger cross-sectional area on the turbine section. So imagine if your AR was picked up a little bit, you had a little larger turbine wheel, and you had a little more compressor section too. Heck, horsepower might keep going up on this little hot six.
Yeah, I think it will.
Food for thought out there. Tell us where you came from in all this development. Looks to me like we originally started with a couple of printed parts, right?
Yeah, so early on in the development process, before we got these carbon fiber parts in, I actually created the design and 3D printed them on a SLS 3D printer, which uses nylon powder and lasers. And this actually creates very, very accurate parts, accuracy down to 0.1 millimeters. And this is what we initially used to test fit in the car to know that this design will fit perfectly.
Yeah, we really had to pay attention because what I really wanted to do was eliminate from having hoses and hose clamps externally. The factory wouldn't do that, If this was a factory GTS or an S model, they wouldn't do that. This would be done the way that they did it. And also when you're adding hoses and hose clamps, it also causes you to have a much sharper radius, which causes a lot of problems too. I mean, air doesn't like to go around an ultra sharp radius.
With our design, if you run your finger inside of it, it's perfectly smooth along the whole entire section. Nothing to cause turbulence right as it goes into the turbo.
And also, one of the reasons for the D shape like this, as opposed to like two round tubes, not only is your cross-sectional area slightly improved by doing this, because we're going up the transition is to a much larger tube here. So when you took the entire volume area, if this is a 2 1/8 inch, well, I don't know, what was the millimeter on this?
I don't completely remember, but I'll have a comparison on the screen right now.
Okay, but what we're gonna see is that total number would be higher, but really the reason with keeping this D-shaped port was that the speed of the mass air here versus the inside is much changed. So that when the demand for air comes, it really comes around this corner much faster. On a cylinder head, if you make most of your power out here modifying the port. This would be like the roof and this would be the floor. When you take away this floor too much thinking you're opening up, boom, the numbers just drop they plummet like a rock. The flow bench never lies. This is really done in a smart manner.
Yeah, these curves are chosen with care.
This is quite a design. So it'll be interesting, the next project then, we'll bring this into the shop, but this will be really sitting right here into the turbocharged area. And all of the hoses, like you're seeing here, will hook up stock. This will just plug in.
Fitment just like factory.
Yeah,
it's a plug-and-play installation.
Yeah, right down to your wires, just clicking right down on top of it. It's done right. And I've always learned if it's worth doing right. And that's what racing is all about. It's doing it right. Yeah, I'm excited to make it happen because I can't wait for further development. We've been tuning this car, and I can tell you it's an exciting car and it's a lot of fun. I've actually had a very nice increase in performance on this, and I can honestly tell you that I've been able to pick up the fuel economy a bit. So it'd be interesting once we get the more efficient inductive onto it, what can we pick up not only the efficiency but the performance? Because with efficiency comes performance. You did a really great job. It's interesting, I don't want to hold everybody up, but it's kind of interesting. This is the factory gasket that goes between the turbocharger and the inductive plumbing. And it actually fits like this. And we were kind of wondering, it's got a built-in silicon seal, just so we're rubber. It's a soft seal right here that clamps down. But you can see, why did they put the seal all the way out there? It was almost like they were thinking about something in the future.
With our design, we actually are able to use this factory seal because of how much larger it is than the original part was. This actually allows for a very nice seal between our part and the turbo, pretty much the same way the factory parts would seal.
Yeah, plus you're able to now put on your cross-sectional area here for the inductive to the turbo is much larger than it was before.
Yeah.
So actually what you're really comparing is like this inductive to that inductive. And it's really tremendously different. Well, thanks for the tour. Look forward to seeing you at the dyno next. We'll take it back to the workshop. We're going to start the installation. First, like I said, we're going to baseline the car, do a nice job at that. We're going to gather a lot of data while we're baselining. We're not just interested in like horsepower and torque. We want to know what's going on. So we are going to be recording a lot of channels. There will be a lot of monitors. We'll get as many as possible. We'll stay tuned. We're going to hit this thing.
Yeah.